What does the future market structure look like for AI Foundation and API companies? How does OSS play a role in the world of ever-scaling model, OSS open source? So today we're going to be looking at a blog post from Elad Gill. Elad is an entrepreneur, operating executive, kind of an advisor, operator kind of figure, but definitely has credit in the technical space. He does kind of know what he's talking about, but more of a VC or operator than an actual technical contributor. But I think it's interesting to look at his view because it's probably indicative of a large amount of people's views, especially people who are going to be investing in the AI market over the next 5 years. So he has a blog post here that's pretty fresh. It's February 15th. Today's the 21st. And yeah, let's get into it. So he originally wrote this a few months ago, but then you have this whole situation with Google and Bard and Microsoft and Bing, and all the big tech giants are kind of gearing up for some battles in the years ahead over AI-based products. And I think we're going to see a different strategy. So kind of open source and research has been the manifestation of AI for the past 5-10 years, right? It's been basically these big companies have internal research groups and they publish all the work that they do. But I think we're entering into a new paradigm where you're going to see a little bit more secretiveness, a little bit more competitiveness. And let's see what Elad has to say about this and what he predicts this market will look like in the future. So he divides the AI world into roughly 3 areas. He calls it LLMs, image generation, and other. So, I mean, right off the bat, this is very clearly a bucketing, 3 buckets designed by someone who doesn't really know what AI is. So these are just the 3 or the 2 largest applications that have kind of come out to the public. So image generation, things like Midjourney, DALL-E, Stable Diffusion. I would say NERF is not at all image generation. NERF is, to me, like a longer play on replacing the 3D stack. So NERF is a disruptive force for the way that 3D is done right now with textures and meshes and companies like Blender and CAD and stuff like that. But it's going to still take probably at least 5 years before we really see NERF and stuff like that dominate the 3D market. Large language models, I think this is where all the attention is right now, pun intended. And basically this is your GPT-4s, your Blooms, your Bards, basically these large transformers that have been trained on huge corpuses of text data, and basically they're AGIs, right? They're general intelligences. They have kind of a very broad general knowledge. They can autocomplete all kinds of things, everything from Twitter tweets to scientific papers and legal documents, whatever you want. And I think these large language models are what's going to be changing our world within the kind of immediate future. All right, other. His third final bucket here are things like robotics, self-driving cars, protein folding. So these are all benefiting from the advancements in image generation and LLM. So within robotics, LLMs are actually becoming popular as a form of kind of commanding robots. The fact that you can now take a text command, convert it into kind of some kind of embedding, and then maybe have a skill or a task embedding in robotics that's based on that. So I'm seeing some advancements in robotics coming from LLMs. Protein folding, also basically the same kind of situation where protein folding has benefited tremendously from LLMs. Not specifically, it's not like they're using ChatGPT to do protein folding, but the transformer architecture and a bunch of other kind of advancements in distributed training and just general rising tide kind of floats all boats situation where protein folding nowadays is actually pretty good, and a lot of biotech companies are kind of leveraging that and trying to see if they can make step function improvements in drug discovery or other biotech applications. Okay, different models and markets exist. However, blah, blah, blah. I'm going to ignore everything in this bucket. I would almost put 3D models like NERF, I would put that in the other category. To me, this is still a little bit out. Okay, when people talk about generative AI, they tend to mix these areas together into one big bucket. In reality, each of these markets have different underlying AI model architectures, compute and scaling needs, high-quality bars, and application areas. It is important to segment them out to infer what futures they might bring. Image generation versus LLMs, very different costs, quality, scale, and segments. Okay, so he's kind of comparing, I guess, the fundamental components of these different types of models from kind of a business perspective, it seems, right? Okay, cost to build cutting edge. Image gen, hundreds of thousands, tens of millions. I would say image generation is also tens of millions. I think that Emad is the Stability founder, Emad Mostaki, this guy. So he had an interview where this is the founder and CEO of Stability AI, the guy who made Stable Diffusion. Yeah, so the company spent $600,000 of its $10 million initial funding to train Stable Diffusion. So hundreds of thousands. Okay, so maybe he's right. I would say that image generation is still more expensive to train than language models. I know large language models, I think the reason that he has tens of millions to hundreds here is because there's more of an appetite to train. People are willing to put tens of millions of dollars to train an LLM, right? These big companies like OpenAI and Microsoft and Google. whereas people are not willing to put tens of millions to train an image generator yet. But image as a modality is just fundamentally so much more higher dimensional than text. So I would think long-term image models are going to be significantly larger and more expensive to train than language models. The model, millions, billions of dollars. Okay. Qualitative need for output, broader range of answers, acceptable, strong qualitative needs for image output, high need for accuracy, actual truth needed. So I think that's the current way that these are sold. So image generation is largely being sold as a art product, right? It's like it basically allows you to create art and allows you to create stuff such as the thumbnails for these videos. These are all AI generated. LLMs, you're not really seeing applications like chatbots. Most of them are kind of, I think the application that most people are really excited about is search, right? And then once you actually have search, you need to have this truth in quotations marks here. I think that the retrieval LLMs are where people are ending up on, where basically you have an LLM that can access a indexed kind of store of all the actual truth information. And we saw in the stream that we did on the tool former, where you can basically augment a LLM with a variety of tools, such as a calculator, a kind of calendar, and a database that has a bunch of actual facts, and then the LLM can be better at giving you the actual truth and not just kind of some confident prediction that is mostly made up. All right. Size of near-term application areas. Huge, extra super massively huge. Size of long-term applications, extra huge if excluding video, extra super huge. Okay, so I mean these boxes don't really mean anything because I would say there's probably more stuff in image gen. The modality of images and video is probably a bigger market than the modality of text. Even though I think the modality of text is a bigger market in the near term, I think the modality of images and video is the bigger market in the long term. Defensibility and moat. So this is the important thing. Like people like Elad here, like these kind of VC people, they're really, this is what they spend a lot of the time thinking about, and this is why we're reading this article, is they spend a lot of time thinking about how defensible is this business, what kind of moat does this business build, and like what is this, what do the companies that use this technology look like over the next year, the next 2 years, the next 5 years, the next 10 years. So I'm super curious what his opinion is, and his opinion is likely defensible via partnerships, brand, and UI iteration, and likely defensible via scale, accuracy, and comprehensiveness. So I don't know if I agree with these. I think this comes from kind of a lack of understanding of like how AI actually works on the part of Elad, but all of these are different forms of defensibility that apply to all of these, right? Scale, I think you're already seeing that, but you're seeing that in both image gen and LLM, right? It takes a huge amount of money to train a large language model and an image generation model, so scale is acting as a barrier to entry for early stage companies. Accuracy, I don't know about that. To me, accuracy, comprehensiveness, that applies to image generation as well, and that kind of is a factor of scale. It's how good your model is at generating images and how good your LLM is at creating text that is truthful. Both of those come down to how big is your model, and more importantly than that, how much data have you trained it on, and what type of data do you have access to? So one of the things that he doesn't mention here, which I think is actually going to be huge, is going to be the data component, right? Are companies like Facebook who have huge amounts of data, right? They've been running this social network for a very, very long time, so they have a huge amount of images and text and messages. Like, is that data set going to be more useful than Google search data set, right? So like how big are the data sets that these different companies are sitting on, and when they inevitably make it kind of closed source and hidden, I don't know what the right word is here, right? But you can imagine a future where Meta and Microsoft and Google are very, very protective of the different data that they use to train their AIs, and in that way, you see differentiation when it comes to accuracy, comprehensiveness, and so on. Okay, open source. Mix of open source and closed source, with open source on potentially equal footing with closed source. I think this is just a factor of the current time. I think, unfortunately, pessimistically, I think that the future of image generation is going to be more closed source, just because people are getting very defensive about their data sets, and I think you're already seeing this with Stability. So Stability, Getty Images. Yeah, Stability AI is getting sued by Getty Images. Getty Images claims Stability AI unlawfully scraped millions of images. I think what you're going to end up seeing is that the companies that have access to a huge image data set that is proprietary are going to succeed tremendously in image generation, and those who don't are just going to flounder. So this is image generation. I think actually Meta is actually the best position, just because of Instagram and Facebook. They have a huge treasure trove of basically images that they can generate, or that they can use to train image generation, and they already have shown that they can do this, right? I think they had Detter Meta. Yeah, so they have like very good computer vision expertise in-house, and then they're also sitting on a huge data set. So to me, image generation becomes more closed source, and I see Meta kind of pulling away from the pack here. LLMs, let's see what Elad says. He says closed source likely to be ahead of open source due to compute. If eventually costs $1 billion, open source likely to lag. So I also think closed source will likely be the case for LLMs, although to me, I actually see a potential open source candidate succeeding here because there is enough text on the internet that is open, that is kind of available, that you can probably train an LLM that competes. I don't see any big company sitting on a proprietary data set of text that is impossible to duplicate. Whereas I do see big companies sitting on huge data sets of images that are impossible to duplicate. So I think the availability of data there's a big difference between the availability of image data and the availability of text data. I think text data is actually secretly more available. Image generation will likely transform multiple areas, including social products and images, graphic and visual design, movies, comics, anime, manga, video games, CAD, architecture, blah, blah, blah. Yeah, it's going to change kind of everything. Performant video opens up in application areas. The range of societally transformative applications for images, while large, may be much smaller than the total surface area for text and language in the very near term. Yeah, I think that in the very near term is the important part. This, of course, may change over time with video, voice, and other interfaces. Right now, most B2B applications are language-centric, while consumer is mixed. Yeah, I just think humans are such visual creatures that I feel like I could envision a future 20 years from now where people barely read text and everything is done via images. While image generation opportunities listed above are all large areas, they are dwarfed by the potential applications of language if you look at corresponding company market cap and revenue. Language is a core part of all B2B interactions, social products, commerce, and other areas. LLMs are likely up to a few orders of magnitude more important than image in the very near term on an economic basis. Yeah, I mean, let's see some data. Let's see what these market caps are. Image gen is cheap to model. Image generation models have seen massive success, can be reasonably trained on reasonably small amounts of dollar compute. I disagree with that. I think that good image generation models are very expensive. Yeah, a few $100,000 to $1 million of GPU time is not, that's not cheap. Nobody else can do that. Like, it took this Elad guy, right, who's a hedge fund dude, right? He sunk like $10 million in order to make Stable Diffusion. Not a lot of people have $10 million sitting around to do that. Image gen quality. Swapping pixels is not the same as swapping words. Image generation has more subjective quality bar than language. Beauty truly is in the eye of the beholder, and even an imperfect image can provide useful output. Maybe I can see how, I guess he's saying that the quality bar for image generation is lower than the quality bar for text. I would disagree with this in the sense that I feel like humans are very, very good at looking at an image and telling you if it's right. There's a reason there's an uncanny valley. We still haven't crossed it, so uncanny valley. Uncanny valley is a situation where a term used to describe the relationship between human-like appearance of a robot object and the emotional response. People feel a sense of unease or even revulsion in response to humanoid robots that are highly realistic. So in order to trick a human that something looks human, right? So like all these robots, you can basically instantly tell. Your brain is very, very good at instantly looking at this picture and knowing that it's not a real human, right? But I would say that if you look at text, there is no uncanny valley in text, right? Text is, we've largely passed the Turing test in kind of its classical definition of like, hey, can you tell if this chat bot that you're interacting with or if this blog post that you're reading has been written by a human or not? I think we're already there in terms of the quality of text versus the quality of images still not there. So I would say that to me, that's kind of proof that image generation and images and video just as a category are harder to create than text. Image gen potential markets. Image generation models seem easier to predict the higher probability path. Most likely we will see a mix of proprietary closed source models, the Disney model, and open source models, Stable Diffusion. Yeah, this is a good prediction. I think that Disney has a huge proprietary image data set, right? They have every single Disney movie, every single piece of content that they have in their content library. So I do see a world where a company like Disney actually has one of the better image generation offerings alongside general purpose closed source tools, Midjourney, DALL-E, and area specific closed source models. Yeah, I feel like these models will be reasonably cheap to train and largely differentiated by IP or specific use case. So a subset of these models will be able to run locally and devices further opening up application areas. Yeah, this is a little bit nearsighted. I think that, people thought that AI was going to be the same way as this, that you would have basically all these narrow AIs that are focused on very specific tasks, and then you're going to have like a kind of broad range of different little companies and startups that each focus on a specific type of task. But then largely what we learned over the past, 3-4 years is that that's not actually the way to do AI. The way to do AI is to have one giant model that's trained on every single type of data, and then it has kind of emergent abilities, right? That a model that's trained on 10 different data sets is more than just 10 times better than models trained on a specific data set. So this idea that you're going to have, for example, a graphic design AI startup that has their own little image generation model, I don't think so. I think that Disney's model that's trained on the Disney data set is going to be better at graphic design than the graphic design model that some random little tiny startup creates. So I think you're going to see the kind of winner-take-all dynamics that you're seeing in LLMs. You're going to see it in image generation too, and it's going to be who has the biggest, baddest model on the biggest, baddest data set. Image gen may ultimately differentiate based on proprietary data sets and training approaches versus raw scale of capital I mean, this is what I'm arguing for, is that long term, that's exactly what ends up happening. Most image gen approaches are based on diffusion models, with some people exploring the transition to transformers or hybrids. Yeah, kind of a lack of understanding there. Diffusion can be performed in the latent space, so you could have a transformer as a feature encoder, and it doesn't necessarily need to be diffusion models. I think we were reading a paper on this stream a while back where they did not use diffusion models. They used a VQ GAN, and they got very good generation results. So to me, that's based on what the papers I've read and what I've seen. It's not diffusion models that are resulting in the kind of step function improvement of image generation. It's the scale. It's the data sets and the compute, which is what it's always been, right? The Rich Sutton's bitter lesson that we like to attribute success to algorithms that are human designed, but the success is not down to algorithms. It's down to basically just the scale. The amount of data that we've been training on has been increasing over the decades, and that's why our stuff is getting better, not because we're coming up with cool model architectures. Other models may also impact the approaches of economics in these models, and therefore the evolution of the industry. In the short term, there's less uncertainty on the world of image generation in the next few years. Open source is likely to continue to play a key role in the evolution of products in this area over time. Okay, so he's largely kind of brushing off image generation and saying that, hey, it's just going to be this kind of smorgasbord of little companies and who cares. But, I don't know, it's a little bit of an ignorant take, but I think he mostly wants to talk about LLMs, and this is kind of the more interesting area now because you have all these big companies kind of starting to battle it out for LLM supremacy. Language includes applications like search, B2B interactions, code, finance, chat, texting, Copilot for everything. Yeah, I think this is the huge application. Right, you can imagine a world where basically, very well put, Copilot for everything, right? If you're a lawyer, you have a little chat GPT that's specific to legal stuff and helps you with that. If you're a doctor, you have a little chatbot that kind of serves as a better version of Google search. This is not only just in some distant future, this is today, right? Like the technology exists to create Copilot for everything today, so we're living in the future already. There are open questions on which of these areas require large language models versus smaller niche ones. To date, the LLMs seem to outperform niche models in some but not all areas. Yeah, this is what I'm saying, is that Elad doesn't realize that this sentence also applies to image generation, where the LLMs seem to outperform niche models. That will be the case in the modality of images and videos as well, where you're not going to have smaller niche models, right? When it comes to image generation and video generation, like the bigger the model, it's just going to outperform, right? So take the sentence, apply it to image generation, and what does that mean in terms of the future you can predict, right? Because think about it, like right now we're talking about a Copilot, or the market for LLMs, like to me, this is the real big applications. You have a little Copilot for like legal people. It's like kind of like a SaaS tool, but like think about a world 5 years from now where Disney has a huge image generation model and it's training, or it's able to generate content on the fly, so it can create Marvel movies for you, right? That is a huge market, right? Automatic content generation. And in a world where automatic content generation is basically the most lucrative market in the world, having the biggest possible image generation model is going to be a huge competitive advantage. Who gets all the revenue? Blah, blah, blah. Okay. LLM market structures. Okay, this is interesting. Let's see what he says. TSMC World, one at-scale winner. So TSMC is a Taiwan semiconductor manufacturing company. So this is basically the company that makes all the chips. So it's kind of the subject of a bunch of geopolitical tension right now, obviously because it's in Taiwan, and then you have kind of the China and the US kind of fighting over influence in Taiwan. But TSMC is the world's biggest outsourced fab. It has nailed process engineering and scale and used the most advanced semiconductor equipment in the world. Its market cap is much larger than any other fab, and it has highly specialized expertise in-house to enforce this. In the TSMC analogy, given the current active market players, OpenAI currently has a lead, being the sole winner. Its current pole position is reinforced via scale and capitalization, and its apparently increasing velocity in aggregating data, talent, know-how, and compute. Google is the next most likely candidate to be the sole winner. Google seems to be awakening to the competitive threat, and other startups like Anthropic character startups could always provide wildcard to the end winner. The TSMC world is roughly a monopoly market, with a sole provider being dominant. This seems decreasingly likely as competition heats up in the market. Yeah, I think that I largely agree with this take. I like the analogy to TSMC, but I would say that TSMC is like, we're talking about manufacturing hardware, right? And in the manufacturing hardware world, it's like the margins that you make are very important, and then your ability to manufacture the best possible stuff is also important. I think there's different dynamics in this kind of manufacturing world than there is in the world of kind of software products, and I think that software products are always going to be more competitive, right? And I do agree with Elad here that likely there's too much activity to end up in a monopoly. At least you're going to have Microsoft versus Google, but likely you're going to have Microsoft versus Google versus Meta versus like maybe a handful of other little long tail startups here. Cloud service provider world. The cloud wars ended up with AWS, Azure, and GCP as the large-scale fierce competitors. So AWS is the Amazon Web Services, which is basically the cloud compute provided by Amazon. Azure is Microsoft's cloud compute, and then GCP is Google's cloud compute. Out of these three, I would say Amazon is, to me, the real winner, because I feel like most people that I talk to, like, they use AWS, right? At least within the technical community. Azure and GCP, they're more expensive, and a lot of the numbers for these guys are like fake, right? So like when you look at Azure, they gave OpenAI a bunch of money, and OpenAI trained on Azure servers and Azure cloud. And Azure's cloud. So Azure gets to say, hey, look at all this usage that we're getting, but in reality, all of that usage is just OpenAI training its own models. And Google does the same thing with GCP, where they kind of use their own cloud in such a way that it seems like there's a bunch of people using them, but in reality, it's just themselves, right? So there's kind of like a lot of like dog fooding and kind of like accounting and usage like number finagling, and that leads to Azure and GCP appearing to be more used and more popular than they really are. But that's just my opinion, so I take that with a grain of salt. It seems like the most likely near-term market structure for foundational language models, but it is early days and the future is uncertain. An oligopoly market for LLMs would be if OpenAI, Google, and one or two other companies ended up with a strong market share split between. Many of the customers I spoke with who use LLM platforms want a second source model to OpenAI, if only to have more bargaining power or to experience more data privacy. One could argue the reason Juniper exists is so enterprises can second source Cisco. The reason to argue for a near-term oligopoly market versus likely fragmentation is due to the capital, compute, data, scale costs currently needed for each subsequently better performing LLM model. So one thing that we were reading about in the paper yesterday is how you can distill, right? So in the paper yesterday, they trained a diffusion model to do this kind of like pix-to-pix. 0 was the name of the paper, but they distilled a GAN from the diffusion model. So you can take a big model and then feed it enough inputs and get enough outputs to train a smaller model. And the smaller model is effectively mimicking the bigger model. So I think what maybe someone like Elad is not realizing is that you don't need to train these things from scratch. And it could be a world where the companies train these big models, like Google and OpenAI, they train the big model, but then other companies simply take the big model and distill their own smaller model. So there is a world there where the cost to train a highly performant LLM kind of goes down over time rather than going up over time, but uncertain. If GPT-3 cost a few million, tens of millions or hundreds of million, and GPT-4 from scratch may be estimated at tens of millions, GPT-5 is a few hundred million, and GPT-N is a billion. Yeah, understatement here. Scale has been proven to be important for many deep learning approaches. The ongoing scaling of capital needs to continue for larger models. For some period of time, a strong moat will exist for foundation model companies, limiting new entrants. Yeah. If eventually it costs $500 million to train each new model generation, not many companies will be able to afford to compete. Yeah, that is also true. The eventual capabilities of a foundation model on a single architecture should in the limit approach an asymptote, eventually removing the competitive advantage. This may take some time and is in the extreme race of asymptote versus AGI, as well as further technological breakthroughs. Moore's law, which is more an observation, lasted longer than anyone expected. Older versions of models may be cheaper to retrain equivalents of, meaning open sources will be a generation behind. Any application using earlier versions of models will no longer need to live on the main platforms and can revert to open source. So kind of his general take is that you'll have kind of an open source equivalent to all the different AIs that is basically one generation behind. You're kind of seeing this. I think there, for example, the Bloom model. Yeah, Bloom is an LLM, and we were using this one on some streams, and it is not as good as ChatGPT, and but I think that's more just the data set that they're trained on. He's putting a lot of emphasis on like the training cost and the training time, but I think he's kind of glossing over the fact that the data set is a much more important component when it comes to the final performance of your model. It's not, the training is important, and it does take a bunch of money to train these models, but it's really the data set that you have available. Semiconductor-like behavior. LLMs are likely to be similar to the microprocessor industry in the 90s and 2000s. Intel had a clear advantage and was always 2 to 3 years ahead. Each Intel CPU design in fab, which is on an 18-month iteration time frame, cost quite a bit more to build than the prior. This, alongside clever sales and marketing, enforced a moat behind Intel and its market. Okay, so this is Texas Instruments, I guess, and the fab cost. So this is the cost of different chips over time. So you can see here how 1975, this is like basically the Moore's law kind of situation going on here, where you have first 64 kilobytes, 256 kilobytes, 4 megabytes, 16 megabytes, 64 megabytes. So you can basically see the actual power of this compute going up very rapidly over time, but then the cost also goes up over time. And he does make a good point that this actually looks very similar, right? where the LLMs are getting significantly better over time, but the cost to create them is also getting significantly higher over time. Chip design cost, fab module construction cost. So chip size, nanometer, nanometers, this actually goes down, right? So over time, the scale, right? The chips get more and more miniaturized, right? They get smaller and smaller. And you can see how we're getting close to, then this is why a lot of people say that Moore's law is like dying, is because it's getting really hard to make these things smaller and smaller. And you're getting to a certain size where like fundamental physics is preventing you from making smaller chips. Latest Intel CPUs were always more performant than the prior. Most cutting edge applications needed the latest. The last generation or two of LLMs may be dirt cheap to train. Okay, prior generations may default to open source. We may end up in a world where GPT-N is at the cutting edge with clear differentiation, while GPT-N-1 and N-2 is cheap and broadly accessible with lower fidelity needs. You assume the foundation model training costs continue to ramp up with each subsequent model, then the next 2 to 3 years is probably the last chance for a startup to enter this market without a deep-pocketed strategic backer such as Microsoft, Apple, or Amazon. This is a good sentence. I do like this. This might be the best sentence in this entire blog post here, where the AGI race, I don't really see another company coming in, right? I think maybe the only thing he's understating here is he's not thinking internationally. So one thing to realize is that I think that China has like 3 times as many people as the US. The US has like 300 million, and then China has like 1 billion people or something like that. Like, yeah, 1.4 billion. So the data sets that China's companies have are significantly larger, right? There's more text being generated. So you can actually see a world where 5 years from now, the LLMs that China trains are trained on significantly bigger data sets and for longer, and they end up being better than the LLMs that Microsoft, Google, Facebook, Apple, and Amazon train. I don't think Apple's in the race. Apple is very bad at AI, and Amazon is not very good at AI. I think the only people in the race are Google and Facebook, and then Microsoft because they bought OpenAI. Startup will need escape velocity from a revenue and technological progress perspective. There may also be interesting tech breakthroughs that could impact this. If the startup invents AGI or a program that can bootstrap by writing its own code and training faster than humans can. Yeah, I mean, this is a weird situation. I don't know. I don't think you can invent AGI in a garage. I think Hollywood gets that wrong. Cloud timing. Despite having the infrastructure to build a cloud platform, it took Google 2 years for its first GCP service and a few more years after that for GCP to be a more complete solution. Azure launched 4 years after the first part of AWS launched. It usually takes a few years for a large company to respond. LLMs may be a similar thing that Google and AWS will need to respond in order to be competitive as cloud providers. AWS is 2006, Azure 2010, GCP 2008. AWS initially actually wasn't for external people. AWS was built to service Amazon's needs internally as a e-commerce company and fulfillment company. And it's only really later that they realized that they could be selling this as a service, right? Cloud computing as a service. And that idea was actually really, really good. The idea of like, hey, we have a ton of server expertise and cloud computing expertise in-house for all these, for our e-commerce company. Why don't we sell that as a service? And now AWS actually makes way more money for Amazon than the e-commerce proxy war, the Alibaba Tencent model. Sometimes companies may compete via arm-length proxies. For example, Alibaba and Tencent often fund and buy deep ownership and then distribute competitive products. IBM used to fund Linux to counter Microsoft, and Google, Apple, and Mozilla all back different branches of WebKit as a sort of browser proxy war. For AI, the reasons to have an arm-length relationship may include PR and safety reasons, the ability for an indirect subsidiary or proxy to have more nimbleness and freedom, financial incentivization, and other reasons. One potential future would be an OpenAI Microsoft versus Anthropic Google versus Stability Amazon or Cohere Meta. These are all made-up pairings. Yeah, I don't know if Amazon would purchase Stability AI. Although I think Stability did train on AWS, so maybe there is a kind of a natural pairing there. Maybe Amazon purchased Stability. That would kind of be I could see that happening. In other words, each incumbent would choose a startup partner to take on the brand and safety risk while buying major ownership. The startup would get access to data distribution, blah, 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 to some extent. This results in roughly the same market structure as two. Yeah, so I think you're seeing this. This is a pattern in technology in general where these large companies, even something like Google, right? The fact that they broke up Google and made a parent company called Alphabet, and then within Alphabet, there's a bunch of different smaller companies. And even with Microsoft, for example, they purchased GitHub, but GitHub still has its original brand and it still has all of its original stuff. So I think the world where these big companies acquire companies, and rather than kind of getting rid of the original company's brand, they keep the acquired company's brand. I think there's other reasons why they do that, and I think that's going to be more and more common, right? Where these big giant companies, they acquire the smaller companies, but they keep the brand and the kind of like separateness. They keep them separate. But that's not necessarily new to tech. Like that's even something like food, right? There's like this graph, all food companies are the same. yeah, this chart. So if you guys haven't seen this, this is pretty crazy. But basically, most of the processed food you buy is actually the same company. So like, for example, Nestle here, like they own all these brands, right? And they've realized that, hey, actually, rather than having everything be Coca-Cola and every time we buy a brand, we refactor everything and make it all Coca-Cola brand, let's just keep the original brand so that people don't even realize that we own this brand. So I think part of it is just big companies are afraid of damaging their original brand and they don't want to appear as a monopoly, so that they keep the brand of the companies that they acquire. And this is rampant in the food industry. And I think what he's referring to here is actually the same kind of thing happening in the tech industry. And it's been happening for some time now, where the acquisitions don't result in kind of a full integration between the acquired company and the acquiring company. You still have separation. Niche models matter, or a major backer of open source shows up. Another version of the world is one in which niche models end up performing roughly well or better than the large-scale models. I don't think this world works. I think this is, to me, is Rich Sutton's bitter lesson. The giant models will just always be better and more general than the niche models. Okay, each early data points. LLMs augmented by niche datasets tend to outperform niche models. Yeah. It's not worth it. This is an unlikely world in the next 1 to 2 years, but may become very important. Massive funder of open source alternative. Maybe the Gulf countries create the oil to AI fund, or a deep-pocketed company views open source foundation models as important to its market structure. If there ends up being enough capital to fund open source alternatives, it would lead to a more fragmented market and world. Another view of the world is that models will commoditize rapidly, but brand, distribution, and product will matter as much or more. Bing is roughly equivalent to Google on many measures, but Google has maintained its market position via buying, paid distribution, and branding. In one future version of the world, we will end up with 2 to 3 core API platforms, and then a federated set of open source or bespoke models to cover numerous use cases. This is the future to me. This is the one that I think is most likely. You end up with 2 to 3 core API platforms. Very similar to cloud computing, right? Where nowadays you basically have cloud computing as a service, and it's incredibly useful because you can basically scale your startup, or you can, me as an individual person, I can decide to pay money and have hundreds of GPUs doing calculating the things that I want, right? Because these 3 companies provide largely the same product, right? They're kind of all at feature parity. So I see a similar kind of situation happening with AIs, where you basically have 2 to 3 core platforms that provide AI as a service through an API, right? And I think these 2, so very obviously Microsoft, very obviously Google, and then I think Facebook is the one that's also going to be very good. Open source versus closed. Big funding sources, or consistently 1 to 2 generations behind. Most successful open source projects have eventually had large corporate backers. Linux was heavily funded. Crypto are the obvious OS counterexamples, although one could argue that given monetization being built directly equated in these groups self-funding, crypto is its own corporate sponsor. Oh, I did not know that Bloom was in part funded by France. That's kind of interesting. So he says, obviously, the Saudis, right? Saudi Arabia has a sovereign wealth fund. They invest a ton of money into startups, and they have just a huge amount of money, like trillions of dollars. So there very much could be a kind of Saudi AI. Scale of compute really matters. Suggesting the medium term, unless a large-scale backer of OS large language models. Open source large language models may end up a generation or 2 behind. I think it's not just the training, it's also the data set. I think open source models are not going to have access to the closed data sets that Google and Microsoft and Meta have, and that's what's going to result in kind of open source models being not as good as the closed source ones. But the most cutting-edge, highest fidelity models for the most advanced uses may stay closed source. When GPT-7 exists, if it costs $500 million to train, then maybe the open source foundation models will have a GPT-6 or 5 equivalent. Compute, scale, and cost over time. Okay, so he kind of predicts an S-curve, which is usually the curve for most technologies. Model performance. GPT-N, N-1. Many industrial labs are increasingly saying they will stop publishing as many results as the competition in the market heats up. This is very sad. You know, as someone who reads a lot of academic papers and kind of is an external member of the AI community, it kind of sucks to me that this AI and ML will become increasingly more closed and secretive. Percent of large-scale AI results from academia, yeah, kind of goes down over time just because they don't have the money to do it. Bottlenecks and approach to scale. A world in which capital acts as a moat is also one in which the sheer scale matters. A money-based moat only exists in a world where we can keep scaling inputs faster than the cost in the industry rises. Image generation is a good counterexample where today the scale of dollars and GPUs is not preventing new entrants. For LLMs, the factor may impact both cost and scaling. At some point, the web will be exhausted as a data source. This is something that I'm concerned about. Like, I feel like we're going to run out of data. Video, voice, code, all books, and all other data sources may at some point be exhausted. One can imagine a future where people are paid to record their lives and passively captured into models. That's what we're doing right now. part of why I am doing these YouTube videos and recording myself, and is because I think that's actually how this will actually be valuable in the future. I think in the future, you will get paid to create data that AIs get trained on. So if you're not recording yourself, you should totally start recording yourself. Everything you do, record it, because the more data you record, the better your immortal AI clone will become. Synthetic data will be increasingly important over time and is already a key component of self-driving car autonomy and other ML-driven fields. RLHF, reinforcement learning from human feedback, is a core component to reducing the need for prompt engineering and training models on specific human-derived tasks. Small models may outperform large models when properly fine-tuned. About this, there's still an enormous amount of optimization to be done at the chip level. Parallel GPU or TPU hacking still has some room to go. Yeah, I think this is interesting for other reasons too. I think that the geopolitical tension and kind of the decrease of globalization and kind of the increase of nationalism is going to change the chip industry, which is very globalized, right? It's a very complicated supply chain with a lot of different countries involved. And I think that there is going to definitely be a shakeup there. You're already seeing it, right? Something like Tesla makes their own chips, Google makes their own chips. Like, you're going to see a lot of very interesting technology and growth and progress in the hardware space and semiconductor space. And I think you're going to see more kind of vertical integration. So if Google makes their own chips and their barred LLM is trained in such a way on their own chips that's very difficult to reproduce, then that becomes a competitive moat. So making your own hardware as a competitive moat, I think, is something that the big companies are going to do, even though they're already doing that, but it's going to become more of a thing. There's a lot of room to optimize the systems and infrastructure side of LLMs. Similarly, differential weighting of tokens by complexity or information content are being explored. Yeah, maybe. I don't know what it means by this. Often when a human is presented, she will pause for a few seconds or a few minutes before acting. Similarly, while enormous emphasis is put on training, more approaches applied at the time of inference could help. So maybe one thing to think about in this space is kind of what the Toolformer paper kind of indicates, where you're likely to, at inference time, you're interacting with smaller, kind of like almost like a custodian ChatGPT, which then, if needed, will go ask a question of like the actual big ChatGPT model, the big LLM. So you're going to have different levels of LLMs that have different availability of different tools. And depending on the task that you're doing, sometimes you're going to be doing very cheap inference with a very simple model that just kind of basically answers your questions. Sometimes you're going to get to do inference on a bigger model that has more context and so on. So in terms of like the best possible way to do inference such that it's fast and cheap, I think there's still a lot of innovation there. New breakthrough architectures. Yeah, maybe, I don't know. Other algorithmic model on top of the transformers. I don't know. I still think that transformers are huge. Medium term, it seems that even if you implement many of these things, scale will create an advantage for LLMs. Yeah. It's not that it will still create, it's that it is the advantage. It's all scale. It's always been scale. It's like that meme with astronaut gun. It's like this meme, and then this guy saying, wait, it wasn't wait, transformers were just scale? And then this guy's like, it always has been, right? When does scale-based value asymptote? Many technologies eventually reach an asymptote, often on an S-curve. Sometimes this curve has fundamental underlying physical drivers. The line width of a transistor will eventually run into an atomic limit, so yeah, we're running into the kind of limits of physics. An open source question is the time horizon over which scaling compute saturates existing datasets and AI architectures. If AI scaling hits the top of the S-curve quickly, the market will fragment rapidly into more players and open source usage. In contrast, if there's a long time horizon to reach the asymptote, the industry structure is likely to stay more static. Yeah, so he's basically saying we don't know what the technological limit is of current AI technology. My fear is that we're going to run out of data, so we're already kind of training on the entire internet, and I think that if you train on every single book, every single piece of text on the image, every single piece of text on the internet, every single image ever created, every single video, every single anything that is digital, you train on all of that. At some point, you're gonna run out of stuff to train on, and then you're gonna kind of start hitting the top of this S-curve, and it's gonna be harder and harder to train something that is 10x smarter. So I definitely see this S-curve happening. I don't know if I see it happening anytime soon, but does value aggregate to platforms or apps? Much of the application value aggregates to the platform as it forward integrates into a handful of apps that do best on it. Microsoft famously bought or killed all the competitors to MS Office. AWS, Azure, and GCP are all massive businesses, and yet roughly all SaaS, enterprise, and consumer companies benefit from these platforms and have aggregated their own value without the platforms forward integrating into them. In general, the very highest quality, highest scale businesses in tech right now own the platform for devices and cloud. However, lots of other platform or API businesses and applications have all thrived in this world. Most likely answer on platforms versus apps is both. Some platforms will forward integrate into obvious applications, while most applications will be standalone and able to create enormous value on their own. Yeah, this is where you want to be if you're an AI startup. You want to figure out how to build on top of the LLM APIs that that OpenAI and Google will provide. So OpenAI and Google will inevitably end up having APIs for their large language models and their other kind of large AIs. And if you build a very compelling, innovative application on top of that, I think that's where all the money will be made when it comes to startups the next 5-10 years. All of the above could be wrong. Things are changing incredibly fast. A technological or performance breakthrough could upend anything. We also still do not know all the big tech companies will react. As such, there's only certainty that we are living through an exciting times. Here we go. There's no way we can read every single ML and AI archive paper. Thanks to Ben Tottenson and Matt Friedman. Cool, so that's a cool little blog post. I think that I agree with most of what he's saying. I agree with kind of this S-curve in being kind of a good model for technology and kind of the way it advances. I like this idea that potentially you have a large sovereign wealth funds offering or kind of stepping into the AI game. I think he didn't talk about China, but to me, China has an underrated data set, right? The amount of data set on the Chinese internet or the amount of data on the Chinese internet is kind of underrated. And I think that if you have a company such as Tencent or Alibaba or Baidu, one of these companies, they can train on that data set. You might get huge LLMs out of China that are better. I think this is, to me, is the model of the world of the future. Is you have basically 2 to 3 core APIs to LLMs offered by kind of Microsoft, Google, and Meta. Very similar to what the compute landscape and compute market looks like now. I think that he's underselling image generation and video, like just video and image content. To me, that is way bigger than LLMs. It's way harder, right? Because the data sets are harder to get and it takes more money to train. But to me, this is the end all be all. LLMs are just kind of, they're definitely going to be huge, but I think that LLMs are going to be huge in the next 5 years. Image generation is going to be huge in the next 10 years. Cool, but this is a nice little article. Yeah, I hope you guys like that. Definitely read this article, and see you guys later.